Our last speaker of the day is Ryan Dunning, and he will be speaking on preliminary evaluation of an IBL Introduction to Proof course for humanities major. Thank you.
I want to thank the organizers for the opportunity to speak here today. What I want to talk to you today about are some of my experiences going through my first couple of semesters teaching an IBL course. Specifically, the course that I was teaching was called Math Concepts 1. That's standardly the equivalent of a Math for Liberal Arts class. That's humanities majors, non-business, non-STEM, and also not Texas State teacher track. Standard topics, it's been mentioned already today. The limitations are not very strict. Sets and logic I see are listed right here, and that's mostly what I stuck with. And my prior experience to this academic year was none teaching this course or teaching IBL at all. Some of my purposes for teaching this class mostly stemmed from my dissatisfaction with college algebra, the way it normally runs. And I feel that many of us here at this conference probably have some of those same dissatisfactions about that particular course. I wanted to offer a more engaging alternative for a significant chunk of those students that might otherwise take college algebra as a terminal math class. I wanted to explore logic, proof, clear thinking, reading, writing, speaking in a math class as opposed to perceived memorization. And I wanted to also offer mathematics in a numberless setting, essentially a numberless setting. And I thought that this would be the opportunity to do that with this course that was already on the books with Math Concepts. The content that I covered in this course, I wrote my own notes and covered logic, which included some truth tables and equivalences. A shorter chapter on the language of proof, kind of outlining what is a theorem, what is proof, what are axioms, what's the difference between the word theorem and the word theory. And chapter 3, I covered set theory, and I'll have some comments about that chapter later. And a very brief chapter at the end on geometry, mostly through existence axioms with a few standard and non-standard models to discuss. And there are a lot of fine points to the operation of the class that I'm glossing over and not including in my slides here, but I did want to mention the grading. I used a grading scheme where everybody starts at a 0, and any effort you make cannot lower your score. So with one asterisk on that, show up and take my final, or else I don't give you a C. And that was one that I stuck to. Otherwise, 25 best homework problems at 2 points apiece, so half of your score for the course is based off of homework. And that's 25 homework scores out of a possible 70 or 80 problems that were available, so certainly you don't have to knock out every single one of these problems, and I recognize that at the start. Some of these would be a tad too difficult. 3 presentations at the board throughout the course of a semester at 6 points apiece, participation at 10 points, such that I was allowing that you could have a bad participation day about half of the time and still earn your full participation points. 2 midterm exams at 7 apiece and a final exam at 8 points. So tests de-emphasized mostly because those proof problems take a little while. We've seen that in any proof course that we've ever taught. A little bit about the operation of the course. Chapter 1, we were doing logic problems, truth table sorts of problems, and sort of parsing some sentences as well. And those problems, I think, were digestible enough that we generally had somebody ready to present a problem, and most frequently we had somebody ready to present the next problem. So most of the class time was spent with students at the board presenting the problems, even if they weren't used to that particular method of course, which none of them were. And even though some of the students were obviously confused in this section, there was still enough widespread understanding, as I said, that problems did get presented, and for the most part presented in order. Chapter 2 was a much shorter chapter. It was just a reading assignment that I had put together, as I said, describing theorem, proof. but no explicit homework problems. I also assigned that reading along with Chapter 1 of a very good book called Fermat's Enigma by Simon Singh. If you're not familiar with his writing, I think it would go a very long way in a math appreciation class and a science appreciation class. I did have one student remark to me that this book should be required reading in any math class, and I'm a tad bit inclined to agree. But I had the students write up their questions and commentaries about these readings and bring those in as fodder for an hour-long discussion. So Chapter 2 was brief, but a sort of necessary transition from a little bit more of the formulaic problems with truth tables towards some organic proofs later on in the course. During Chapter 3, one good thing that I had happen was that some students that had jumped ship back in Chapter 1 came back on board that very first day in Chapter 3. And if you speak to the experts, and I heard from the experts a little bit too late to change this on this particular matter, but tradition says to start with one subject and stick with that subject. So if I were to do a set theory at all, I should do set theory throughout the whole semester. But I had spoken to someone else after I was already committed to this particular setup, and they calmed my fears by saying that this very thing that did happen could happen. I was leaving myself open for somebody to jump back on board, and three people out of 21 in a class came back right then, including one that I had, for all intents and purposes, written off. However, we did hit a standstill on the content, and I'll address that a little bit later. So some of the structure of the day-to-day changed a little bit. We spent some more time working in small groups in order to get ourselves close to solutions, and I think that was a function of the fact that the problems became a little bit too hard, that I didn't get my proximal zones building up to the problems that I was eventually handing to them in Chapter 3. Chapter 4 was a very, very brief section on geometry, and unfortunately it lands with about 2 weeks left in the semester, and the students land at that point in basically one of two camps. With my grading system, you either have a grade that you're comfortable with and you're willing to take those last 2 weeks off, or you have not quite the grade you want and you are scrambling to bump your grade up about 1 or 2 letter grades, which was still possible if you left yourself enough homework problems still to gain and enough presentations to make and a final exam. So the atmosphere in the class was a little different those last couple weeks because we were a little anxious about the time. We didn't want to spread out and ask a lot of open-ended questions. We wanted to get the job done and get our points before all the time was up for the semester. Now, what I had done as part of a reflection process on teaching IBL for the first time was to give my class an entrance and an exit survey. And the questions that I chose, some were taken directly from Alan Schoenfeld's surveys from this 1985 article. Some were adapted a little bit to better suit my course, and I added a few questions of my own. I should point out this survey came to my attention from the past couple years at this conference when Brad Bailey spoke about IBL versus traditional lecture pre-calculus at, I believe it's North Georgia College and State, with 2 of his colleagues there. And they had used some of Schoenfeld's questions, more aimed towards task efficacy in pre-calculus. Now, I do want to point out, I also gave this entrance and exit survey to my traditional lecture college algebra class last spring. And I do want to point out this is traditional college algebra lecture versus IBL math for liberal arts. So it's not a scientific comparison. I did just want to get some perspective, though, from my college algebra students because my efforts to do IBL for humanities majors was born out of a dissatisfaction, as I said, with college algebra. So I thought that these courses were kind of close to each other, but for the reason that it's not an honest scientific experiment, I don't have all of those results for you. I have the raw data, but especially the categorical questions, those numbers right now don't mean a whole lot, and I intend to add to those over time. But I do want to share with you, I think, the main spirit, which comes from this one question. On the entrance survey, this question is phrased as, what do you expect to get out of this course? And on the exit, I replace that question with, what did you get out of this course? And so what I want to show you here are some responses, first from my IBL Math Concepts course. And I think these are very short. I'll let the words up there speak for themselves. So this is before and after on one particular student in the concepts class. Another one who's perhaps going for a teaching qualification down the line.
You can read them because it's hard to read from the back.
Okay, fair enough. This first one, hopefully a better understanding of mathematics. That was the before response, and what they got out of the class was a better understanding of, this time phrased as logic, and how to apply it. Another before response, I hope to learn new processes and new formulas en route to possibly double majoring to receive my teaching qualification. But after, this same person said, I received the ability to truly express what is on my mind in order to solve problems. Just some beautiful language there related to communication of ideas, which I think is key to any math class. The necessity to present our problems in a perfectly formatted way will take me far. Another person's before, they expect to get a better knowledge of math, and what they did get was confidence in doing math. Before, somebody wanted a better understanding of solving math problems, but after their comments said that they used to not enjoy solving math problems, but this course was entertaining to them. It was never introduced to them in a way that was found to be entertaining. Somebody else beforehand hopes to get a better understanding of math, and afterwards the idea of concepts has intrigued me and may help me when I take my LSAT. More than a few people in this audience of humanities majors are on something of a pre-law track and eventually will take the LSAT. So going through good if-then arguments based on a set of rules, those are classic LSAT questions, and they appreciated the training on that. Here's probably the best one, and this was perhaps the mode of the responses on the before college credit. But this person did say that they learned how to think conceptually from this course. Someone else says that I expect to at least know how to apply it in my life, and afterwards, on down the line, they say they learned that mistakes are normal, and it is whether you learn from them or not that makes you a successful student. I think that's the last there of my IBL responses, and I do want to point out that about a year ago at a Texas Section MAA meeting, Mike Starbird was giving a workshop on IBL, and he gave us a little group task to sit and talk amongst ourselves and come up with student learning outcomes, what we want our students to be able to do 10 to 15 to 20 years down the line, and you've seen that list already today from Dr. Balls. And what we had noted right then that day was that everything that we put up on the board that we wanted our students to be able to do on down the line, there was no mathematics content on that list. Knowing the quadratic formula was not on that list. But what I was surprised to get from my IBL responses on these surveys was most of those sort of outcomes covered. Not frequently, but not the same outcome mentioned by lots of people, but usually lots of outcomes mentioned by one person. I was pleased with that. Again, I want to point out the traditional college algebra lectures, this is not a valid control group, and over time I might figure out how to best do that. And the responses here were not as tragic as I was expecting them to be. One person, however, this was the one on the top of the stack, a better understanding in basic algebra is what they were expecting, and they learned a lot about algebra and equations. A completely neutral before and after that was at the top of the stack. Other very common responses, I expect to brush up on my skills, and that's essentially what they got, and that's for the most part what I think college algebra is. One other student says they expect to get how to do math better, and they did mention there were some things that they still couldn't grasp. And I think that's a fair assessment here on the college algebra. I think a student walking in on college algebra at the beginning has pretty clearly defined expectations for the most part, whereas with an IBL class, with a class called Math Concepts, I think the expectations are a little less well defined, and I think that's another aspect of why the after results are a little bit more scattered, but scattered in such a way that I think reflect all of our aims. Any of us who try to teach a course IBL, I think we shoot for those kinds of goals, for our students to start to recognize those kinds of goals. Let me state also here some of my dramatically called grievous mistakes that I made in my rookie season here. In the notes, my assessment is that I used way too many words. My intent at the start writing these notes was to be very, very clear and point out a lot of different things that can go wrong. And so when a student came to a proof that needed to call upon an old result, I was frustrated that they weren't finding that old result. So I think I need to take the notes that I have and whittle them down some more. I mean, they're sparse as compared to a textbook, but you go to Giblum and you'll find note set after note set that's much sparser than what I wrote. And I do recognize that would most likely be replacing one customer dissatisfaction with another, but I think it's the one that we standardly try to embrace in a more method class, that less is in fact more on the notes. I did overreach on the set theory content. I do believe that they might have been better served with a few more example-driven problems to build up. They also struggled with use of symbols, so I'm also kind of considering, in addition to numberless math, perhaps symbolless math, but that opens up its own problems. I also let a few too many of those awkward silences go uninterrupted. So I do want to advise the potential first-timers out there, definitely get your chair's support, your dean's support on this. Do your homework, seek your advice, but in the end go with your gut, because only you will be teaching your class. You know what's going to work for you. And I do heartily endorse, even if you have to enforce it strictly upon yourself, self-reflection is a very, very informative process, especially on this kind of course. We should all do these on all of our courses, but it is advised by some of the experts to write a little diary of your experience with each lecture, and I'm here to say that worked out very well. And so again, to those of you potential first-timers, give it a shot. I think you won't be disappointed. Questions?
Yeah. So how did the students like it compared to? I mean, have you taught the same course, not IBL, to get a feel?
I have not, and that's one of the factors in not having a control group. In the fall, I was prepped to teach this as IBL, and I was not scheduled to teach this course at all in the spring, so I got it again on short notice, and short enough notice that I couldn't have respun it in a traditional lecture in the time that I had. So instead, I polished up the IBL notes that I had. The students, I do feel Certainly some of them were adventurous, and just a few of them visibly more so adventurous than the others, but for the most part, everyone else seemed to understand that this is how the class would work, and they went along with it. And I was shocked I didn't have a mutiny on my hand either time. And so the fact that I was still standing at the end, I took that as a success.
He had another question.
Yes.
Excuse us, please, for a few minutes. Thank you.
Was your course actually entitled Math Concepts 1?
I believe it's just called Concepts 1, but it's MT 1301, so they know it's a math class.
Okay, because the one would suggest to me that there's a Math Concepts 2.
There is a second semester on the books, but it almost never gets taught, and it's probably been decades. And it is in there as a 2-semester course in the Texas Common course numbering system, but it's a terminal math class because this audience only needs one math class for their degree plan.
Thank you.